Okay, hi everybody. So we are starting Unit 5 now. Unit 5 deals with chemical reactions, and this is basically what everyone thinks of when they think of chemistry. We're going to be mixing stuff, finding out, writing different chemical equations, using different formulas, and seeing what type of products are made. We will get to blow some stuff up. So let's kind of continue. Let's look at what are we going to learn in this unit. First of all, you're going to learn how to read and write formulas. Now you got to Unit 4, crisscross rule, metals and nonmetals, nonmetals and nonmetals, covalent bonds, being able to write those things from words. We are going to call upon those skills again. So if you are struggling with that, you need to make sure and consult your notes from Unit 4. Percent composition. Well, what the heck does composition mean? I'm going to try and write on this. So let me, there we go. Composition is basically what is something made of. So let's say I've got water, H2O. Okay, so we are actually going to be able to calculate what is percent hydrogen in water. And that's important for a number of reasons. Basically, if you're starting with water and you're reacting to form oxygen gas and hydrogen gas, you want to know how much hydrogen are you going to get out of it. So you're going to be able to write chemical equations given names. You are already able to write formulas, but now we're actually going to have a whole different equation. So something like hydrogen peroxide decomposes into hydrogen gas and oxygen gas. You'll be able to write hydrogen peroxide, which is H2O2, yields, which is this arrow that you're going to learn about, hydrogen gas, H2 plus O2. And so you see I'm adding these little subscripts and everything, and you're going to be able to learn how to do that in this unit. You're also going to be able to balance simple and complex equations. So you've probably got a taste of balancing when you did when you were in middle school, but we're going to be doing something kind of, it's like balancing on steroids. Classifying types of reactions. So we're going to do a series of reactions. There'll be a day actually. I'll do some demos on some videos. You'll get to do some reactions, and you're going to be able to tell me, is it a combustion reaction? Am I blowing something up? Is it a single replacement, double replacement? These are terms and stuff you will learn throughout this unit. Predicting products. You mix two things, what are you going to get? Product. That means what you're going to get. You're going to be able to do that. And lastly, this big old word, stoichiometry. Stoichiometry is basically the foundation of chemistry, specifically introduction to chemistry. And I was actually just talking with a professor at Alabama. You need to be able to do this if you're going to get into introductory of chemistry. So let's look at our first lesson. Make sure you're taking notes as you go. This is 5.1. You need to tell the difference between molecular and empirical formulas. Well, in order to tell the difference, you need to know what the heck those things mean. So what is an empirical formula? Well, the definition at the beginning of your course pack, it says it's the simplest or most reduced formula. Okay, it's the simplest or most reduced formula. Easy way for me to remember this, empirical starts with E, reduced, R, I just think of ER. In an injury, you go to the ER, empirical means reduced. Molecular. This is the true formula. This is the complicated one. It is not reduced. And the best way to describe this is actually just to look at an example. So let's go ahead and do that now. Okay, mad skills. You've got two steps here in order to tell the difference between empirical and molecular formulas. First of all, these little subscripts, these numbers that appear at the bottom of a written equation, you need to find the greatest common factor. So I'm going to call upon your math skills to be able to do that. If no greatest common factor exists, that means it's already reduced. So the formula is the empirical formula. So for our first example, C8H18, okay? Let's go ahead and do this. Our subscripts are 8 and 18. We got to find the greatest common factor. Now, if you're like me, I like to make a little factor tree. So 8, what goes into 8? Well, 1 does. 1 goes into everything. 8, the number itself. 2 also goes in there. 2 times what gives me 8 is 4. So 1, 2, 4, and 8 are my factors. If I look at 18, again, 1 in the number itself. 2 goes in there. It's an even number, so it's 2 and 9. And I actually get 3 and 6. 3 times 6 gives me 18. And there's nothing else in there that's a factor of 18. So if you're struggling with this, make sure to YouTube something or come see me, go to your math teacher. Make sure you should be able to find the factors of numbers. And we'll be doing a lot of practice of this, so you might just learn it as we're doing it. So what number is common, meaning the same, out of both of these factors? Well, we've got 1, clearly, and we've got 2. Those are the only ones. Well, which one is greatest? Clearly it is 2. Okay? So we've got the greatest common factor. GCF is equal to 2. Okay? And we are going to divide. We are going to divide to find the empirical formula, or the reduced formula. Remember, empirical is ER, reduced. So we find C8 and H18. We're going to divide each one by the greatest common factor, which is 2. 8 divided by 2 gives me 4. 18 divided by 2 gives me 9. Replace that reduced. Now it is C4H9. And I can check to see, is this reduced? Can I reduce this anymore? 4 and 9? Nothing can go into those except 1. So this is the empirical formula, or abbreviated EF. Let's look at another example. H2O2. Hydrogen peroxide. This is the stuff that comes in the brown bottle your mom or dad pours it on you when you have cuts and it burns like heck. We will get to use hydrogen peroxide, a much stronger solution later on in lab than what you buy at the store, that little brown bottle. That brown bottle is actually only about 3%. We're going to use something that's 30%. And it has a cool kind of chemical reaction. Many of you guys already see this 2 and 2. Well, these are going to have the same greatest common factor, 2 itself. So I can just divide by 2 and divide by 2. And the reduced formula is just H1O1. Does that look right? Hopefully you're shaking your head. You remember, we don't have to write 1. We don't have to write 1. 1 is just assumed. So this is just HO. So what have we done? We've given molecular formulas, the true formula. We're reducing it by finding the greatest common factor in order to find the empirical formula. So this is how you're going to be able to tell the difference. Can it be reduced? Okay, Hg2Cl2. This one's pretty basic. You can already see 2 and 2. I'm just going to skip this one. You guys already got this. HgCl. I found the greatest common factor. I divided by 2 for both of them. C3H6. Okay, so this is something that's going to require me to do a factor tree. So let's go. We got 3. We've got 6. Well, what goes into 3? Just 2 numbers, 1 and 3. What goes into 6? Well, 1 and 6, duh, 1 and 6, clearly. And 6 is an even number, so I know 2 goes in there. 2 times what gives me 6 is 3. What is the greatest common factor between these two? This is where you could pause me and you could test yourself before I give away the answer. Clearly you see the number that is biggest, and is the same in both of them, is 3. So I'm going to come back over here. I'm going to divide by the greatest common factor because that's what my mad skills tell me what to do. Divide by 3. Divide by 3. 3 divided by 3 gives me 1. C1. 6 divided by 3 is 2. And I get C1H2. But again, do I have to write that one? No, I do not. I do not. So the correct answer is actually CH2. Okay, let's look at number 5. Na2, ooh, we've got 3 of them here. So since we've got 3 subscripts, we actually need to do a factor tree for all 3 of these. So let's write them out. 2, 2, and 4. Well, this is pretty basic. What goes into 2? 1 and 2. 1 and 2. And 1 and 4. It's an even number. I know 2 goes in there. Greatest common factor is 2. It's the only one that's common between all of them, and it's the biggest. So I divide by 2 for each. And for Na, 2 divided by 2 gives me 1. Now I'm not going to write 1. I don't need to. C, 2 divided by 2 gives me 1. And O, 4 divided by 2 gives me 2. So NaCO2 is the correct formula. Now remember, what type of formula is this? This is not reduced. This is my molecular formula. Molecular. Okay? Empirical is my reduced. Empirical formula. So I'll use those abbreviations throughout class. I'm not going to write those big words each time. It's just going to be MF and EF. You got to know it. Okay, you've got 5 more practice questions in your course pack. I'm not going to go through these, but I just want to give you the answers. So this is where you could pause me, kind of test me, and test yourself, and we will see how you do. So for H2O, well, look, this is 1. This is already reduced. So the empirical formula, is the same as the molecular formula. You can see Mr. Liddell back there. He doesn't know, but he's on camera. This one, greatest common factor, divided by 4. Oops, not 2. 4. 4 should give me CH2. This one's going to give me C2H3. Next one, C7H12. This one was tricky. It is already reduced. There's nothing that goes into 7 that goes into 12 except 1. So it's already reduced. If I divide by 1, I divide by 1, it's going to stay the same. And lastly, hopefully you're stuck here. Well, not hopefully you're stuck, but this is an easy place to get stuck. You've got to combine this. Oops, ignore that. I don't know what that was. Okay. Pop up. C2. I've got 2 C's, so I'm actually going to rewrite this so it's easier. I've got 3 H's here, 1 H here. So C2H4, and then 2 O's gives me O2. Well, what goes in all these? You can probably spot it from right away. It's just 2. So I'm going to divide by 2, divide by 2, divide by 2. And I get C1, H2, O. Okay? So, let's recap. All of these are my empirical formulas. They are reduced. All of these are my molecular formulas. And yes, in some cases, the MF can be the same as the empirical formula. Like we had 2 of those. It's totally fair game. Okay? And that's kind of where we wrapped up. Continue recording here. If you look, I had just finished, I think it was page 3 in your course pack. When we come back, we'll look at how to calculate molar mass. Okay?